Hello everybody, here we are again with another lesson, 4.5, solving polynomial equations is what we're looking at on this lesson. So we're going to be solving equations, but these equations are going to be polynomial equations. We'll see how we'll be using factoring to solve them. So we will be finding solutions of polynomial equations and zeros of the polynomial functions. Eventually, more in the part 2 lesson, we'll be looking at the rational root theorem and irrational conjugates theorem. But for now, in this part 1, we're really just mainly focusing on solving these polynomial equations and even doing a little bit of graphing along with that. So to get started, let's just start with a little joke of the day. What do you call a duck that steals? That would be called a robber duck. So there you go, a robber duck. Okay, so here we go. We're going to jump right into this on page 99 of your notes. We're going to look at these 6 problems here. It says solve the equation, and what we have here is it's a polynomial equation, and it's going to be got a equal sign in here. So we have to first of all set this equal to 0. We want to see it always in standard form, which is in descending order equal to 0. So number 1, it's already set up that way. But on these other ones, we're going to have to adjust them first before we can actually do anything else. Get them first set up in standard form equal to 0. So we're going to use factoring on all of these. We're going to use all our factoring tools that we've learned in the last section to just factor these. And then remember, each factor is the answer, really. You can set each factor equal to 0 using zero product property, and then you have your answers. So let's jump into this. Number 1. We want to first look for our GCF, and the GCF here you can see is R. There's an R in each one of those. So R is going to be factored out, and then what's left, we're going to reduce it by R. Just take an R away, so it's going to give us a 36R squared, and then minus 1. We took the R out, but we still have a 1 to put here, because R times 1 would be the R there. And now we got to look at what we have left here in the parentheses. It's 2 terms. And it's a square, an R squared, so we want to see, is it a difference of squares? It is a difference, so that's good. And they are both perfect square terms. 36 and 1 are both perfect squares. So this can factor again to 2 more binomials. So we're going to have R. Now on the outside, GCF is still there, but now inside these binomials, we're going to break the 36 up to 6 times 6. So it'll be a 6R, because it has an R squared, 6R and 6R up front. And then the back will have a 1. So one's going to be a positive 1, the other one's going to be a negative 1. The signs are just always different when you're doing the difference of 2 squares. So 1 times 1 is 1 in the back. So that's our final factoring. And on the last lesson, that's where we stopped. But now on this one, we actually want to solve the equation. What is the answers for R? There's 3 answers for R here. We're going to set each of them equal to 0 separately. So one answer I can already see right here is 0. R does equal 0. But now this one, I'm going to need to solve for R. So when I solve that one for R, first subtract 1 from both sides, and then divide by 6. And so another answer for R is a negative 1/6. And this one, we're going to add 1 first, and then divide by 6. So divide by 6 next when we get 1/6, positive 1/6. So there's our 3 answers for R, a 0, a negative 1/6, a positive 1/6. All right, going on to number 20. First of all, on this one, we got to set it equal to 0, so I need to bring this term over to this side, making sure it's in descending order as I'm doing that. So I'm going to add 60x to both sides. So now it will look like this. So 60x will actually go at the end, because these two have x to the third, x squared, and then my 60x would go here at the end, equal to 0. So now it's in standard form, it's in descending order, equal to 0. Okay, so we're going to look for our GCF first. So I can see, well, 20 can go into these other numbers, so I can factor 20 out. I can also factor an x out, because there's one x in all of them. So 20x is what I'm factoring out. That's the GCF. And then I'm going to reduce every term here by 20x. So that will give me now this here with x squared here. Taking 20 out, take 1x away. 80 divided by 20 is 4, with 1x left there. 60 divided by 20 is 3. And there's no more x's because I got factored out. So now we have a trinomial, and when we factor trinomials, we could always use the star, but this one, it can be used by the simple method where we don't really need the star. We can just look at that number 3 here. So we're going to factor that to 2 binomials. So 20x, our GCF, is still on the outside. And the simple method would just put the x's up front here. So x and x would go up front. And then we'd ask ourselves the question, just what two numbers multiply to give us 3, that add to give us 4. And so we could see that that's going to be 3 and 1. They're both going to be positive here because this 3 is positive, and so they're both going to get the sign of 4. So they're both positive. Okay, now that's our factored form. They're all prime factors at this point, and now we just set each factor equal to 0. So on the first one, 20x equals 0, I just went straight to saying x equals 0 on that one. Because if I say 20x equals 0, well, 20 times 0 would be 0. So that's always going to be x equals 0. So if you have a GCF out here with a variable, that's always going to be a 0. The binomials, though, will be something different. So this one we're going to have to subtract 3. And we get x equals -3. There's another answer. We can call that another 0. This one we just subtract 1, and x equals -1. So there's our 3 answers for x. These could be called the x-intercepts, it could be called the zeros, it could be called the roots of the function. Any of those would be the same thing. Number 3, we're going to first need to bring these over together. So actually, since the m to the 4th is positive on this side, I'm going to probably bring this term over to the other side, subtract the 3m squared from both sides. So I have my positive 75m to the 4th, and then my negative 3m squared behind it equal to 0. So you always want to make sure that your leading term should be positive. That's going to be always the best. So this was our leading term out of this polynomial function. Okay, so now we want to factor out the GCF. Well, I know 3 can go into 75, so I can pull out a 3 and I can pull out 2 m's. So I'm really going to pull out this whole term right here, 3m to the 2nd power. That's going to come out as the GCF, and then reduce each of these by the 3m squared. So 3 goes in 75 25 times, so it'll be a 25m squared, and then just minus 1. We took the whole thing out, so we still have to have a placeholder there for that term, because when we multiply back with the distributive property, I would need to get back up to here. So now what I have left in the parenthesis is got an m squared, so I'm thinking this might be a difference of 2 squares, and it is a difference. And 25 and 1 are both perfect squares, so that does make a difference of 2 squares where we can factor this to 2 more binomials. So keep our GCF on the outside. And then this is going to be 5m and 5m up front. So we're going to see a 5m plus 1 on one of them and 5m minus 1 on the other one. So 5m's and then the 1's plus, 1's minus. So that gives us all our prime factors there. So now we just set each factor equal to 0. And again, like I said, I'm just going to go straight to saying m equals 0 from this GCF. That's always going to be a 0 out here from the GCF. This one will give me something different though. I'm going to subtract 1 and then divide by 5, giving me m equals -1/5. And then on this one I'm going to add 1 and divide by 5, so giving me m equals +1/5. Again, if I'm going too fast, you can go ahead and pause the video at any time and catch up. So again, those are our 3 x-intercepts, or our 3 roots, or our 3 solutions. Okay, number 4, on this one, the highest exponent I see is this y to the 4th. That's negative where it is, so I really need to bring this one over here so it's positive to go in front of all of this. So I'm going to bring the y to the 4th over, add y to the 4th to both sides, and then behind that will be my minus 13y squared, my plus 36. Okay, so that gives me a trinomial. There is no GCF here on this one. So it's a trinomial that we can factor to 2 binomials. So it can be factored to 2 binomials because it's just like our simple method. We have a 4 here, and half of 4 is 2, and that's right there in the middle. So that works just fine. We can put our y squareds up front. So I'll have y squareds going up front to break apart that y to the 4th. And then we ask ourselves the question, what two numbers multiply to give me 36, that add to give me 13. And so you think about those two numbers, 3 times 12, that's not going to work. 9 times 4, that does seem to work. Yeah, 9 plus 4 is 13. So those would be the good numbers to put in there. And they're both going to be negative because 36 is positive here. It means they're the same sign. They're both going to be this sign here. So they're both minus. So now we look at these and we see some y squareds in both of them. We want to see, okay, well, they're both minus signs. Are they both difference of squares? And they are, because 9 and 4 are both perfect square numbers. So this one here, the y squared minus 9, we can make that into two more binomials for itself. Put the y's up front, and then this will become a 3. So y plus a 3 and y minus a 3 is in these ones. So y plus 3 and then y minus 3. So the y squared gets broken apart to y times y, and the 9 becomes 3 times 3 and plus and minus. We'll do the same thing with the y squared minus 4. It's another difference of squares there. So two more binomials, and we're going to say y plus 2 and a y minus 2 will be these guys. So y plus 2, y minus 2. So again, the y's get broken apart. 4 is 2 times 2, 1's plus, 1's minus. And so now each one of these is going to be set equal to 0. I'm just going to go ahead and just kind of change their signs, because that's really all we need to do on this one. You've got to do it a little quicker. We can see, well, I'm going to just subtract 3 here. I'm going to add 3 here. I'm going to subtract 2 here, add 2 here. So we're going to see what y is going to equal a negative 3 from that one. Y will equal positive 3 from the next one. And y equals negative 2. And from the last one, y equals a positive 2. So there's all my answers. There's 4 answers for y on this one. Notice the exponent was 4, so that's the possible amount of answers that we could get is 4, and we got all 4 different answers. Okay, number 5 on this one, this negative 1 is over here, and we should really bring that over. Just add 1 to both sides to set it equal to 0. That will go at the end of this 4-term polynomial. And so now it'll look like that. So now it's in standard form. There is no GCF, so we're just going to go to factoring by grouping. So we're going to group the first 2, group the second 2, and then factor the GCF out of each group. So out of the first group, they're going to have an x squared in common. We're going to factor out an x squared. So we factor out x squared. We reduce the first group by the x squared, so that's going to give us 2x minus a 1, because we're factoring out the whole x squared there. So we've got to put a 1 in its place. 2x minus 1 then. This one has the negative sign in front of the second group, so there's a little twist here. We've got to remember to change this sign here at the end. So there's nothing else in common other than 1. We're just going to factor out a negative 1 on that one. So 2x is going to be here, but we're going to change the sign here of this to be negative 1. So 2x minus 1, which matches the other binomial here, 2x minus 1, tells you that the grouping worked. So that is one of the factors of this 4-term polynomial. 2x minus 1 is a factor of that. The other factor is what we factored out. The x squared minus the 1 is the other factor. So there's our 2 factors from the grouping. But on the x squared, we need to look at that to see, is that a difference of squares here? It is the difference. 1 is a perfect square because 1's a perfect everything. And so this can be factored to 2 more binomials. So keeping our first one here, that's prime already. But now this one can be factored to 2 more. So we're going to see an x plus 1 and an x minus 1 on this one. So x plus 1, x minus 1, those are our 2 factors of the binomial x squared minus 1. Now each factor here would need to get set equal to 0. And then we just solve for x on each one. So then we're just going to add 1 here, then divide by 2 from the first one. So we have 2x equals 1. And then divide by 2, x equals a positive 1/2. So there's 1 answer for x. The next one we're just going to subtract 1, so x will equal a negative 1. And the last one we add 1 and x equals positive 1. So there are the 3 answers for x. Again, notice the highest exponent, our degree was 3. So 3 was the number of possible answers we could get for this one, and we did get all 3. You can't get more than 3, but you could get less than 3. It's possible to get less than 3, or less than what that degree says. Number 6, on this one we got actually a couple terms here, but we got to figure out where is the leading coefficient, or leading term, which is the highest degree. That's the 8c to the third right here. So it's positive where it is, which means I need to bring these 2 over to this side to set it equal to 0. So I'm going to be adding the 20c squared, subtracting the 50c to bring them both over here, and then just make sure it's in descending order when we're writing these down. So 8c to the third will go first, then a positive 20c squared, then a negative 50c, and then last will be that minus 125, and it's equal to 0. So now again, we want to look for any GCF on this one, and I don't see any GCF on this one. So we're just going to go straight to grouping because it's 4 terms. When it's 4 terms, we try the grouping first. So we're going to group the first 2 and group the second 2, and factor the GCF out of the group just like we did on 5. Again, you can always stop the video and try the problem and then play it play it and just see if you got that correct. Alright, so we're going to factor out on this one between 8 and 20. We can factor out a 4 and a c squared. So 4c squared factors out, and we reduce it by that. So that's going to give us a 2c for the start, and this one's going to give us plus a 5 in the back. So 2c plus 5 is in the binomial. This one also has a minus in the middle in front of the second group, so we're going to be changing the sign of this last one as we factor out a negative. So between 50 and 125, I know 25 can go into both of those, so I can factor out 25. So we're factoring out 25, and we reduce that. 25 goes into 50 2 times. That'll be a 2c here. And it goes into 125 5 times. We got to change the sign, though, to be plus 5 for that one. So now the binomials are matching. That tells you grouping is working. And that is going to be one of the binomials for the answer, or for the factor here. So 2c plus 5 is a factor of this 4-term polynomial. The other factor is 4c squared minus 25. That's our other factor. And since it's a c squared, we got to look at it to see, can we factor it again? Is it a difference of squares? And it is a difference. Both 4 and 25 are perfect square numbers, so that can factor to 2 more binomials. So keeping our 2c plus 5 here, this will become 2 more binomials here. And we'll see it's going to be 2c is going to be up front, 5 is going to be in the back, so a 2c plus 5 and a 2c minus 5. Alright, so set each factor equal to 0. And since we have two of these same binomials, these are the same thing, we only need to actually solve for one of them. So on this one, there's a possible of 3 answers, but we're really only going to get 2 different answers because it's got a kind of a double or a repeating factor here. So this one we're going to subtract 5 first, and then we can divide by 2 to get a negative 5 over 2. The other one we add 5 first and then divide by 2 to get a positive 5 over 2. And so those are the 2 answers for C on this one. Even though one of them, this one, is actually considered a repeating answer, it's a repeating solution. Okay, so this next section of problems is going to require us to do a little bit of graphing. We are going to solve them just like we did, but we're going to also graph and sketch the graph as well. So there's just the top of page 98. If you go over there, you look at the vocabulary word. The vocabulary word says repeated solution, and that's just when a factor appears more than once, that is a repeated solution. And you can write that down. That's one thing you can write down for that vocabulary, that it's a factor that appears more than once. But what I want you to really write down are these 2 bullet points next to that. So this is really what you need to copy down here on the top of page 98. So when a factor is, when that repeated solution, if it's a factor that's more than once, then it's going to be something like this. If you look down at the example, here's an example of one. Once they finished this, they solved this here. You can see their answer's got x plus 2 squared and x minus 2 squared. So there's 2 of those, and the exponent is 2 on these ones. On both of them, they're 2. It's an even power. So that would be like this one here. And we can start with this one since we're talking about the even powers. It says when that factor is raised to an even power, that repeated solution is raised to an even power, then the graph touches the x-axis, but it doesn't cross the x-axis at that number. So at that number, so at the number here, which would be like -2, once you solve it, once whatever that x-intercept is for that factor. But if it's an odd power, if this power was 3 or 5 or something like that, or even 1 for that matter, even if it was just a 1, then if it's raised to an odd power, then the graph crosses the x-axis at that point. So it will go through the x-axis at that point. If there's just one of those factors, or if it's raised to a 3rd power or even a 5th power, it's going to cross through. So as you can see, here's the graph of this one. So it's not crossing at these numbers at -2 and at 2. It's just touching, just like it said here. It's going to touch the x-axis, but not cross the x-axis at those numbers. Okay. Also, another thing to keep in mind is that the y-intercept, this number down here, -32, is always your constant of the function. So whatever the constant number is, that's always going to be your y-intercept. We also, to kind of know how this is going here, knowing end behavior, where these arrows are going to be, is also something to keep in mind. So we need to kind of go revisit that real quick on this end behavior. We looked back at this at 4.1. This was in the notes on 4.1. But I just want to show it to you again, so that just look at that leading coefficient. If the leading coefficient well, I guess if the degree is odd, leading term, if that degree is odd, then it's going to be 1 arrow's up and 1 arrow's down. But if the leading coefficient is even, then the arrows are both pointing in the same direction. So that was like the one we just saw here on this one, where it was both pointing in the same direction because our leading coefficient was even. It was a 4. This degree, the actually coefficient of this one, the leading coefficient here, is a negative number, so they're both pointing down. That's also what this is saying. If your leading coefficient's positive, when it's even like this, they're both pointing up. If it's negative, they're both pointing down. But when it's odd, we know they're going to be pointing in different directions. So it kind of, they're always going to be on the one on the right side. You can see, kind of just look at the one on the right side here. If it's positive, it's going to point up, which means the left side will be pointing down. It'll be going down and then up. But if it's negative, then it'll be pointing down. The one on the right side will be pointing down if it's negative. Okay, I also put this here just to kind of tell you what that end behavior was for the end behavior. So that's what we talked about in 4.1. So let's go on to numbers, the next 7 through 10 is next. Okay, so on these next 4 problems it says find the zeros of the function, then sketch a graph of the function. So we're going to find the zeros just like we were doing on 1 through 6. Okay, first thing we got to see is what's in function form here. So we're just going to make the f of x equal a 0. We're just going to make it a 0 instead, so we can solve for it. It's in standard form equal to 0 right now. We want to factor out the GCF, which we can see is an x squared. So we're going to factor out the x squared and then just reduce everything by that. So it'll be an x squared minus an x minus a 12 now from what we have here, as we reduce by the x squared. And that just gives us a trinomial here. We could use the star method, but it could just be the simple method. We don't have to use the star on this one since it has a 1x squared. So we're going to keep, I'm going to put it down below the graph now. So we're going to keep the x squared out there and make 2 binomials out of this. So we're just going to put the x's simply up front when it's a trinomial like that, simple method. And then what two numbers multiply to give us 12, that would subtract to give us a 1. Well, that's going to be 4 and 3. So it's going to be a minus 4 and a positive 3 there. It's supposed to be different signs because it's negative 12 here. The bigger number is going to be negative, so that's 4 getting negative, and 3 will get positive. And then we just solve again just like we did, getting those x-intercepts. That's what we're looking for here. So set each factor equal to 0. So we have x squared equals 0, which we know is just going to be 0, like I said before. That GCF will always just be your 0. And then you have this one, it's going to be a positive 4. This one will be a negative 3. So when you subtract 3, you get negative 3. So those are our x-intercepts. That's where it's crossing the x-axis. But it is got 4, it's a degree 4 here. So since it's even, it should be going the same direction. The graph should be going the same direction. We could also look at the y-intercept. The y-intercept, since it's not there, as far as there's no constant in this one, the y-intercept would be 0. If you plug in 0 for x everywhere, the answer that would be 0. So the y-intercept is 0. And then end behavior. If we look at the end behavior is going to be degree 4. It's an even degree, so they're both going the same direction. And it's a positive, so they're both going to go up. So our arrows, I'm just going to kind of mark it off here, are up here. The arrows are going to be going both up like that. And so now as we graph this, I'm going to just show you the graph. You can also go to Desmos graphing calculator and you can type this in and see it as well. But we can see where we're going to put the important information. Oops. So here's the graph. So you want to put your x-axis way at the top of this and your y-axis going down through the middle. They are numbering the x-axis by ones. They're going by ones on the x-axis, but they're going by, looks like fives. Yeah, going by fives on the y-axis. 5, 10, 15, 20. So going down below here, going by fives, -5. That way we get the whole graph on our picture here. And so you have your x-intercepts, and you could put those down. You got 0, there's 0 right there. You're going to have 4 going on there, and you have -3 is over here. So those are the important points. And we're going to go down and up and down again and up. So it's going to go, kind of doing that kind of thing like a roller coaster. Now notice that this one here is not going to go above. For one thing, the y-intercept stops it there as well. But this one is just going to touch it and then go back down, because this one had a repeated solution with 0. So when it was a repeating solution, it was just going to touch the x-axis and go back down. But these two, which they were just odd powers, right? There was just an odd number of those. So there's just a 1 of those. That means it's going to go through. So as we can see, it's going to go through this and keep going up. It's going to go through over here at +4 and keep going up. All right, going to number 8. Let's first factor out a GCF, which in this case would just be, looks like an X on this one, but it does have a negative sign in the front, so we really should factor out a -X. Your GCF is going to want to be negative if your leading coefficient is negative. So we're going to factor out the negative. Oops. Alright, so sorry I lost my graph over here. This was a graph that I drew down here. So your sketch is probably more like mine. I showed you what the answer was more specifically like, though, and this one I drew it a little differently. But draw it like the one you saw before. Okay, on this one we're going to make this a 0 here, and then factor out that -X. So we factor out -X from this, and it's going to give us a +4 now with an x squared, and then a -12x. It's changing all the signs, notice, because we factored out a negative. It's going to be now +9 here without that x. And so now we have a trinomial again. We could use the star on this one. It does have a 4 in front. Or you might recognize that this is a trinomial square, which it is, because 4 and 9 are both perfect square numbers. If you multiply those together and get 36, 36 is 6 times 6. 6 plus 6 is your middle number. And this last one is positive, so that does make a perfect square trinomial. But if you did the star, then you can still do that. We're going to put a -X on the outside, our GCF there, and we're going to factor it to the two binomials. So the star method would look like this. Your +36 is up there, -12, 4 x's are on top, and the 6 and 6 are down here. They're both -6's. But you would want to reduce the sides, though, but you're getting exactly the same thing on both sides. You're going to eventually get a 2x minus 3 on both sides. So there's two of them exactly the same. So as we solve this, we really only need to solve for one of these 2x minus 3's because it's a repeated solution. It's repeating twice. So in this one, -x equals 0, x will just equal 0 again. And that's always going to be true for the GCF. It'll just be the 0. This one, you're going to subtract or add 3 and then divide by 2. And so it's going to give you a 3 over 2, positive 3 over 2, or you could think of it as a 1.5. That might be easier to actually graph on the coordinate plane. So we do have only two separate x-intercepts, 0 and the 1.5, but this one is a repeated one, which tells you it's just going to touch the x-axis and then not cross it. It's going to go back the other way. This one, it will actually cross the x-axis at 0, okay, because there's only one of these. So as far as our end behavior, we know that the y-intercept on this one again is 0 because there was no constant, so that's the constant is the y-intercept. And then the end behavior on this one, it's degree 3, so we're going 1 up, 1 down. And since the leading coefficient is negative, the one on the right here should be down below. So it's what we're going to see. I'm going to put a little mark here. That's going down this way, and it's going to be then up on this side. And so then our graph will look like this. So there's our graph. You can just put the coordinate planes right through the middle and right down the middle, and looks like we're going by ones everywhere, so everything is going by ones. So right at 0 is an x-intercept, and at 1.5 or 1.5 there's the other x-intercept there. And so you can see on this one, as it's going to come down through the 0 here, it's going to cross through, it's going to eventually turn the corner, and so it's going to turn the corner down here at actually -2. And this is, you can see this on the Desmos calculator, and it's going to go up and it's going to touch here. So it will touch because it's two of these. It's going to touch and then go back down. It's not going to cross through this x-intercept, it's only going to touch it and go back down. Okay, problem 9. We got 4 terms on this one. We want to first start by putting 0 over the f of x, just to show that we're going to make it 0 so we can solve the equation. And there's no GCF on this one, so we're just going to factor by the grouping. So group the first two, group the second two. Out of the first group, I'll pull out a GCF of x squared, and then what would be left would be an x plus 4 on that one. And since this is a negative, we're going to pull out a negative number here, which will change the sign of this last one. And since 6 goes into 24, the GCF there is 6. So pull out -6. So when I do that, x will still be here, and I'll change this to a positive, and that'll be x plus 4 in there also. So another matching binomial, which the matching one is a part of our answer. That's the factor for the answer. So one of the factors is x plus 4. The other factor is the x squared minus the 6 of what we just factored out. And now we set each factor here equal to 0, but before we do that, x squared, we want to just check, is this a difference of squares that we can factor? It is a difference, but 6 is not a perfect square. So that is not factorable. It is prime the way it is. So we just now have to set each factor equal to 0 and solve. So the first one's easy. It's just going to be -4. The other one, we add 6 to both sides, but it is an x squared equals 6, so we have to take the square root of both sides, like we learned when we were solving quadratics with square roots. So we take the square root then of both sides, and here's where we ought to put that plus or minus symbol down. So x is equal to plus or minus square root of 6. And because we're trying to figure out the x-intercept of the graph, then we should find out what actual decimal that is. It's approximately 2.4. So plus or minus 2.4 then is what we have for our graph. Now on the graph, our x-intercept is this last number here, -24. The constant is always the x-intercept of the graph. As far as end behavior goes, it's got a degree 3 polynomial. So one arrow is up, one arrow is down. And since it's a positive leading coefficient, that means if you look at the one on the right here, positive means it's going to be up here, going up, and then it's going to be coming down in this that side over there. So it's going to be going up on the right, but on the left it'll be going down. And so here is our graph. So our graph will look like that. There's the arrows, as you can see. And our key points here, we have a -4, so -4 is there, and then kind of a plus 2.5, minus 2.5, there you go, or 2.4, sorry. They said 4, 5, it's about the same thing though. So there's your points right in there on those two spots. So they're going by 2 on this graph, so go down 3 boxes, draw your x-axis going across, draw the y-axis going straight down. So on the x-axis they're going by 2s, on the y-axis they're going by 5s again. And so then you can see as you're coming up from here, because the arrow would be here, up from here, it's going to cross through all of these x-intercepts because there's only one of each. There's only one of each of these. Even though this is a plus or minus, they're two different answers. So it's going to come up, go through it, go back down. It's going to hit that -24. There's your y-intercept down here. It's going to go through that, come back up, and then go through that last point, that last x-intercept. So again, you can always use Desmos to help you graph those. Okay, so on number 10, we're going to again put 0 here over the f of x and solve this one. It's a trinomial, so it's got the 4 terms. This one can be used by the simple method with just the x to the 4th. We can break that apart to x squared and x squared, 81. We can see that's going to be two numbers that multiply to give us 81, that add to give us 18 is 9 and 9. So this actually is a perfect square trinomial as well. So it's going to be 2 binomials equal to 0. We'll start with the x squareds up front and then the 9's in the back. It's going to be -9 on both of them because they're both the same sign. They're both going to be this sign here, negative. which creates two difference of squares. They're exactly the same thing. They're two difference of squares. So we could see that we're going to factor, one of them here to x plus 3 and x minus 3. Those are your difference of squares on that one, the x's, and then the 3's from the 9. The other one will be exactly the same thing, another x plus 3, x minus 3. So really there's two x plus 3's, there's two x minus 3, so we have some repeating solutions on this one. So we're just going to see, okay, x plus 3 squared, and we have an x minus 3 squared. So when we set each one equal to 0 to solve, we don't need to solve for all four of them, just these unique two. So x plus 3, we're going to subtract 3 there, get x equals negative 3, and the other one we get x equals positive 3. So those are our x-intercepts. There's only two different x-intercepts on this one. So to figure out the y-intercept, that's the last number here, 81 is the y-intercept. That's where it's going to cross through the y-axis. As far as the end behavior, where the arrows are supposed to be pointing, it does say degree 4, which is even, so they're pointing in the same direction, and since it's a positive, they're both pointing up. So they're both going to be pointing up here, so I marked that off there. So this is going to be kind of a W shape as well. And so here's what our graph will look like. You can go ahead and put the x-axis at the very bottom, that last box there, and then the y-axis going straight through the middle. And it's going by 1s on the x-axis, but on the y-axis it's going by 10s. So every box is worth 10 on the y-axis. And so that takes you, so we put our x-intercepts down, so there's our negative 3, there's our positive 3, and since they are repeated solutions and they're repeating twice, an even number of repeating, it's going to touch and then just bounce back up. So it's going to come down first, touch that x-intercept, bounce back up. It's going to go up to the y-intercept and then come back down, touch the other x-intercept, and bounce back up. And the Desmos calculator can show you exactly what that is. You can see it on the calculator as you plug that into the calculator. Alright, so that concludes this first part of the lesson. So the next part will be on the next video. So I'll see you there.